Have you ever looked at the night sky and thought, what if we're only seeing the surface? Because that might be exactly what's happening. For decades, we believed we had a pretty good picture of the universe. Stars, galaxies, clusters, black holes, a vast but understandable structure. Then the James Webb Space Telescope looked deeper, and what it revealed wasn't just more galaxies. It revealed something underneath them, something structural, something that looks disturbingly like a skeleton. Scientists call it the cosmic web, but that name makes it sound harmless. What JWST is detecting goes beyond pretty images of distant stars. It's uncovering the large-scale framework of the universe itself. Vast filaments of matter stretching across unimaginable distances, invisible to Hubble, hidden in earlier observations, now suddenly clear. And here's where it gets uncomfortable. Galaxies are not randomly scattered. They're arranged along enormous strands, like beads on cosmic threads. Between those strands, vast emptiness, gigantic voids where almost nothing exists. If you zoom out far enough, the universe doesn't look chaotic. It looks organized, structured, almost biological, like neurons in a brain or veins in a body. And that's where the phrase comes from, the skeleton of the universe. But skeletons support something. They are not the main event. They are the framework, which raises a dangerous question. If this is the skeleton, what is the body? For years, telescopes like Hubble gave us breathtaking images, but they were limited. Infrared detection at JWST's level changes everything. It allows us to see ancient galaxies forming along these filaments, tracing the scaffolding that has existed since the early universe. Meaning this structure isn't recent, it's foundational. It shaped how galaxies formed, how matter clumped together, how gravity sculpted reality. Without this invisible framework, we might not exist. But here's the part that makes scientists pause. The majority of this structure isn't made of normal matter. It's dominated by something we still cannot directly see, dark matter. We infer its presence because of gravity. We see how galaxies move. We see how light bends, but we don't know what it is. So what JWST may be showing us is the visible trace of something fundamentally invisible. Like frost outlining a window, you don't see the air, but you see the pattern it leaves behind. And if that's true, then we are not just discovering new galaxies, we are mapping the underlying architecture of existence. And once you see structure, you can't unsee it, because structure implies order. Order implies rules, and rules imply something deeper than randomness. The universe isn't just expanding, it's built, and JWST may have just showed us the beams holding it up. So what exactly is this skeleton? Imagine the universe right after the Big Bang. Not stars, not planets, just energy, extreme heat, tiny fluctuations in density. At first, everything was almost perfectly uniform. Almost. And that almost changed everything. Because in those microscopic irregularities, tiny differences in density, gravity began to pull slightly harder in some regions than others. Over billions of years, those slight differences grew. Matter clumped together, pulled more matter in, and slowly, filaments formed. Enormous strands of matter, stretching across hundreds of millions of light years. These filaments connect galaxy clusters like highways, and where multiple filaments intersect, that's where the largest structures in the universe exist. Superclusters, massive gravitational hubs. Between them, voids, regions so empty they make space look crowded. Now here's where James Webb changes the story. Hubble could see galaxies. JWST can see deeper into infrared, meaning it can detect older, more distant galaxies, closer to the beginning of time. And what scientists are noticing is that even in the early universe, these galaxies were already aligning along these filaments, which means the web formed incredibly early, earlier than we expected. That's not just a cool visual detail, that's structural. It suggests the cosmic web wasn't an afterthought, it was foundational. The universe didn't randomly form galaxies that later organized. The structure was there first, like scaffolding before the building. And here's the part that keeps cosmologists awake at night. Normal matter, the kind that makes stars, planets, and you, only accounts for about 5% of the universe. The rest, dark matter and dark energy. We don't know what dark matter is made of, we can't see it, we can't touch it, but we can see what it does. It bends light, it pulls galaxies, it shapes motion, and according to current models, Dark matter is what forms the backbone of the cosmic web. The visible galaxies, they're just glowing dust, stuck along invisible gravitational highways. So when JWST reveals this skeleton, it's not just showing stars, it's tracing the influence of something we still don't understand. It's like seeing footprints in snow, but never seeing what made them. And that raises a disturbing possibility. If most of the universe is made of something invisible, and that invisible substance determines the structure of everything, then what we call reality is just the illuminated surface of something deeper. We look at galaxies and think they define the cosmos, but they might just be decoration, surface-level effects of an unseen framework. And if the structure is dominated by dark matter, then we are living in a universe built mostly from something we cannot perceive. That changes perspective, because suddenly, we are not observing the universe itself. We are observing its glow, its outline, its reaction to deeper forces. And if JWST is helping us trace the true architecture of the cosmos, then we are no longer just mapping stars. We are mapping the hidden framework that determines where everything can exist, including us. If the James Webb Space Telescope is truly revealing the skeleton of the universe, then we need to ask something bigger. Why does the universe have a skeleton at all? Because skeletons are not random. They are load-bearing structures. They determine where everything else can grow. In your body, your skeleton decides your shape. In a building, the steel framework determines the rooms. In the cosmos, the cosmic web determines where galaxies are allowed to exist. That means the largest structures in reality were decided long before stars formed, long before planets cooled, long before life emerged, before Earth, before the sun, before anything familiar. The architecture was already there, and we are living inside it. Now here's the unsettling shift. For centuries, we thought we were discovering the universe piece by piece. But what if we are only now discovering that it was structured from the beginning? That it had a framework, a blueprint shaped by forces we still barely understand. Dark matter doesn't glow. It doesn't emit light. It doesn't interact like normal matter. Yet it dominates the gravitational architecture of the cosmos, which means the visible universe, everything we can see, is just a decoration on an invisible structure. And that changes perspective in a quiet but profound way, because we tend to think of ourselves as observers of the universe, but we are also products of its structure. If the cosmic web had formed differently, galaxies would be different, stars would be different, planetary systems might never stabilize, life might never emerge. Your existence depends on how dark matter arranged itself billions of years ago. That's not poetic, that's structural, and JWST is helping us see that structure more clearly than ever before. But here's the deeper consequence. When you look at images of the cosmic web, zoomed out far enough, it resembles something strangely familiar. Neural networks, brain cells connected by filaments, electrical pathways forming a massive system. Scientists are careful with this comparison, and we should be too. It doesn't mean the universe is literally a brain, but the similarity is unsettling, because it suggests complexity at scales we struggle to comprehend. The universe isn't just expanding into emptiness. It is organized, layered, connected, and we are tiny nodes embedded inside one of its filaments. Not central, not isolated, but structurally positioned. JWST didn't just show us prettier galaxies, it exposed the beams behind the walls, and once you see the beams, you realize the house was never random. The terrifying part isn't that the universe has structure, it's that most of that structure is invisible, dominated by something we still can't explain, which means the majority of reality is hidden from us. We're not looking at the full picture. And if this is just the skeleton of the universe, then the biggest question isn't what holds it together. It's this: what larger reality is it supporting? Because skeletons don't exist for decoration. They exist to hold something up. And JWST may have just shown us we've only been staring at the surface. For more curiosities and mysteries of the universe, like and subscribe to the channel.